Okay, so in this video, we're going to be discussing three-factor medication problems. And it's three factors because it's based on dose, weight, and time, right? So when medications are ordered for infants and children's, the dosage of the medication, it could be in grams, milligrams, micrograms, it's based on the weight of the child. And that has to be considered so we can make sure that we're giving a safe dose. And as to how much medication the child can receive, it could be written or asking you what is the dose for a child per dose or per day. So we know these are three factors because they have three elements in the order. So in this problem on the screen, it says the safe dose for Lasix is 2 milligrams per kilogram per dose. So it's asking you to solve a very specific problem. So what is the dose for a child weighing 10 kilograms? So remember, we always question and ask and read our orders. We have to, it could be asked as a recommended dose or a safe dose, but the questions will ask you about the amount of medication that you're going to give. Is it going to be per day or per dose? Per day would be in a 24-hour period. Per dose is if they ask you for a specific amount given each time the nurse gives the medication. All right, so let's talk about how we're going to solve it. And if you have practiced, you can pause it now. But otherwise, I'm going to go right into the problem. So we always look for the given, and the given quantity contains 3 parts. And in this question, it says 2 milligrams per kilogram per dose. All right, so the numerator is the dose. Much like two-factor, we always start the numerator with the actual dose of the medication. In this case, it's 2 milligrams. And we're going to put that over the weight and time. Now, I know dose doesn't, how does that represent time, Professor K? Because it's asking you a specific time that you're giving a specific dose. But let's just walk through it. It'll be weight and time, whether it's day or dose, okay? So what is my wanted? Well, the wanted in this question is asking you, what is the dose? And when I look at my problem, the only thing that represents a dose is milligram. It's saying 2 milligrams. Milligrams is the unit, is the dose. So I'm solving milligrams. So how many milligrams am I giving for this child each dose? All right. So this is how we set up these problems. So I've used this in my problem, and the only thing I really have left is 10 kilograms. So I need milligrams in my numerator and dose in my denominator. Well, I have milligrams and I have dose. So now I just have to get rid of kilograms. So how do I get rid of the kilograms? I use what's in my problem, 10 kilograms. I'm able to cross off my kilograms, and guess what? That is it. I've used this. So now I know that I have to have a specific strength, milligrams, for each dose. That's the safe dose for a pediatric patient. So 2 times 10 over 2 times 10 is 20, and 1 times 1 is 1. So the safe dose for Lasix for a child that weighs 10 kilograms is 20 milligrams each dose. Now let's look at this problem. The recommended dose for a medication is 8 micrograms per kilogram of body weight per day. So what does that look like if it was written out completely? It would look like this, 8 micrograms per kilogram per day. That's what that means. It's just written out. 8 milligrams per kilogram per day. That's what it's asking. And it's saying, what should the daily dose be for an adult weighing 20 kilograms? Well, that's actually, it should say a child. 20 kilograms is not that much for an adult. So it's saying, what should the daily dose be for an adult weighing 20 kilograms? So I need a dose, and the only dose in my problem is micrograms. And it's saying daily, every day. Daily is day. So I start my 3-factor because it has 3 elements, 8 micrograms per kilogram per day. Well, I have micrograms and I have the word day, so I just have to get rid of kilogram. and I use what's in my problem. I can put that over 1. That gets rid of kilograms. So now I have micrograms in my numerator and the word day in my denominator. So now it's just math. 8 times 20 is 160. 1 times nothing is 1. So my answer will be 160 micrograms per day. And that is the recommended dose per day. That is what this patient should receive per day. So if the doctor said, I'm going to give it 4 times a day, you know that he would not give more than 160 micrograms in that total day. So that's how you do 3-factor. You set it up. Numerator and denominator 3-factor. And what makes it different from 2-factor is now we've added time. In this problem, it says the recommended dose for a medication is 0.6 milligrams per kilogram per day. So again, if you want to write it out, and I encourage you, 0.6 milligrams per kilogram per day. What should the daily dose be for an adult that weighs 52.2 kilograms? So I'm solving for the dose, and the only unit available is milligrams, and it's per day. Daily, day. So I start my 3 factors the same way. The strength in my numerator and kilogram per day in my denominator. So I have milligrams and I have day, just what I need, but I have to get rid of kilograms. So what do? I look to my problem. And in my problem, the patient weighs 52.2 kilograms. Put that over 1, that gets rid of kilograms. So now I have everything I need to solve my problem. So now it's just math. So 0.6 times 52.2 is 31.32. 1 times 1 or 1 times none is 1. So remember your rounding rules. Greater than 10, round to the whole number. So 3 is under 5, so I do not round up. So the recommended dose in a whole day is 31 milligrams a day. In this question, what is the recommended dose of a medication? 0.9 milligrams per kilogram per day. So again, that's 0.9 milligrams per kilogram per day. It's asking what is the daily dose for an adult weighing 145 pounds? So 3-factor, the strength, 0.9 milligrams per kilogram per day. And what am I solving for? The daily dose. So the only unit that's available in dose is milligrams over day. So I have milligrams and I have day. And I have to get rid of kilograms, but the weight available is in pounds. So what's my conversion? 1 kilogram is equal to 2.2 pounds. I'm going to use that. 1 kilogram is 2.2 pounds. That gets rid of my kilograms, but now I have to get rid of pounds. Go to my problem. The patient weighs 145 pounds. Put that over 1. That gets rid of pounds. I look at my problem. I have milligrams. I have day. Now it's just math. So 0.9 times 1 times 145 is 130.5. And 2.2 times 1 or none is 2.2. When I divide 2.2 into 130.5, I get 59.31. Knowing my rounding rules, I round anything greater than 10, I round to the whole number. 3 is less than 5, so I don't round up. So my answer is 59 milligrams a day. That is the recommended dose for a patient that weighs 145 pounds. Okay, so here's another problem, but this one has more conversions, and this is why we tortured you to make you remember all of those equivalents and conversions. So the recommended dose for a medication is 1 milligram per kilogram per day, and that's going to be given twice a day. But they're asking a very specific question now. What is the correct 2000 dose, meaning at that specific time, in micrograms for a child that weighs 5 kilograms? So let's break this down. What is my given? My given is 1 milligram per kilogram per day. All right. But it's asking me, what is the correct dose at this specific time. So this patient is getting it twice a day. I just want to share this with you. If somebody in a hospital is receiving a dose twice a day, they're probably going to get it at 8 a.m. and then 8 p.m. They'll get 2 different doses equal times apart. But they want to know what time, what you're going to give for this specific time, one of these specific times. But they're also asking you for in micrograms. We still set up our problem the same way. We start with the given, 1 milligram per kilogram per day. But our wanted is what? Micrograms per dose. So when you have this set up, you have to start thinking about what are my conversions? We always start with the given. What is our wanted? But what is our unit path? Remember that term? What is our unit path? It's ordered in milligrams, but they want micrograms. So I have to start thinking and jotting things down. I know that 1 milligram is equal to 1,000 micrograms. Okay, so right away I'm thinking that. So what do I do to get rid of my milligrams and change it to micrograms? Well, I use my conversion. So I say 1 milligram is 1,000 micrograms. That gets rid of my milligrams, and I have the first part that I need. How do I get rid of kilograms? Well, I use what's in my problem. Patient weighs 5 kilograms. Put that over 1, that gets rid of my kilograms. But now I have day. How do I get day to dose? Well, we get day to dose by using the number of doses they get every day. And this is why you had to remember those abbreviations. So I can get rid of day by writing the word day. Every day, this patient is getting 2 doses. And when I write that, I can cross off the word day, and now I have doses. Okay? So that's why you have to know what BID, QID, TID every 4 hours, every 6 hours is, because you're going to use them when you need to know how much to give a specific dose for. All right? So this is where you add the BID, TIDs, when you have to know a correct specific dose. So now that I've gotten rid of all of my unwanted, I look at my problem, everything is gone that I don't need. I have the micrograms and I have the word dose. So now again, it's just math. So 1 milligram times 1,000 times 5 is 5,000. And 1 times 2 is 2. And when I divide 2 into 5,000, it's going to give me 2,500. And that is what? 2,500 micrograms per dose. So I'm going to give this little child 2,500 microgram every dose at 8 a.m., 8 p.m. And that's how we figure out dose specific. But this is where you have to use your powers of memorization when it comes to your conversions. Here's another. 0.05 milligrams per kilogram a day. It's going to be given 3 times a day. The patient weighs 58 pounds. The medication is labeled 1 milligram and 1 milliliter. How many milliliters of medication will you administer for the 9 a.m. dose? So this one has a whole lot of information in it. But we always look for our given first, and the given is the order. So I start with my order, 0.05 milligrams per kilogram per day. What is my wanted? Well, this question tells you exactly. They want to know how many milliliters will you give at that dose. So I'm solving for my wanted is milliliters per dose. All right. So if you know how to start and where you're going, you can figure out that unit path by just plotting things in there to get rid of the unwanted. So it doesn't matter where you start first. So I've already used this in my problem. So how do I get rid of milligrams and get milliliters? Or do I want to get rid of kilograms first? Or do I want to get rid of day first? It doesn't matter. So let's start with kilograms. How do I change kilograms? My weight is provided in pounds. Well, right away, I got to think I need a conversion. What's my unit path? 1 kilogram is 2.2 pounds. So I'm going to use that in my problem. 1 kilogram, 2.2 pounds. That gets rid of my kilograms, but now I've got pounds. So then I go to my problem. 58 pounds over 1, that gets rid of my pounds. So I've used that. Now, how do I get rid of milligrams? I go to my problem. And right here, I have 1 milligram and 1 milliliter. So I can say 1 milligram, and why am I putting it in the denominator? Because I can cross off diagonally. 1 milligram is 1 in 1 milliliter. Look at that. I have the first part of my problem. But now what's left? The word day. So I know I got to put the word up here, day, but what am I putting underneath it? Well, every day they're getting 3 doses. A TID is 3 doses. Gets rid of my day, and I have my doses. I look at my problem over, everything is eliminated except for milliliters and dose. So now it's just math. So 0.05 times 58 is 2.9. And if my math is wrong, I'm so sorry. 2.2 times 3 is 6.6. And when I divide 6.6 into 2.9, I'll get 0.439. And remember the rounding rules, less than 1, we round to the hundredths. 9 is greater than 5, so I round up. So I'm going to give this patient 0.44 milliliters each dose. All right, now this one has a different unit of measure, but that's okay, because you guys are pros, you know how to set up your problems. So again, I look at it, it's a 3-factor. It's got 3 elements in the order. I've got available meds, I've got a weight. So I know what my given is. It's my order, 20 units per kilogram per day. And they want to know, what is the dose you're going to give at a specific time, 8 a.m.? So I got to find, how often am I giving this? So we always start with the given, and that's the order. So 20 units over kilogram per day. What is my wanted? They want the dose that you're going to give at a specific time. So the only thing I know and can see is that it comes in what? It comes in milliliters. And I need a dose. Calculate the dose. A specific time dose. So what is BID? That's 2 doses every day. That's what BID means. So how do I get rid of units? I use what's in my problem. 140 units in each milliliter. That gets rid of my units. I have the first part here, but now I got to get rid of kilograms and day. How do I get rid of kilograms? The patient's weight is in pounds. 1 kilogram is 2.2 pounds. Now I got to get rid of pounds. The patient weighs 120 pounds. Get rid of my pounds. And cross it off if you get it. If you used it, cross it off. So now I'm left. What do I got? I got to get rid of day. Well, every day, there's 2 doses. That gets rid of the word day, and I have dose. My problem is done. I've gotten rid of all of my unwanted. I'm left with my wanted, and now it's just math. 20 times 1 times 1 times 120. 2,400, I hope. And 2 times 2.2 times 140 is 616. And when I divide 616 into 2,400, 3.896. My rounding rules, 1 to 10, I round to the 10th. 9 is greater than 5, so I round up. So I'm going to get 3.9 milliliters for each dose. The recommended dose for a drug is 0.5 milligrams per kilogram per day, given TID. What is the correct 1500 dose in micrograms for a patient who weighs 12 pounds? Well, I got a lot of information in there, but I always look for my order, my given, 0.5 milligrams per kilogram per day. It's given 3 times a day, and it's asking me a specific dose, so I need that 3 times a day. And they're asking for a specific amount, a specific unit of measure. They're asking for micrograms per dose. I gotta wait. So I already know I got some conversions. You can write all over it, whatever it takes. And I got milligrams, so I know that 1 milligram is equal to 1,000 micrograms. So I think I got everything I need. I know TID means what? 3 times a day. So these are all my conversions that I need to think about for my problem. So 0.5 milligrams per kilogram per day. So it doesn't matter where you want to start. Let's start getting rid of the milligrams. So I know 1 milligram is 1,000 micrograms. It gets rid of my milligrams. I have my micrograms. Now I got to get rid of kilograms. So the patient weighs 12 pounds, so I got to use my conversion. So 1 kilogram is 2.2 pounds. It gets rid of my kilograms. Now I need to get rid of pounds, so I know the patient weighs 12 pounds. Get rid of that. Awesome. Gets rid of my pounds, but now I got to get rid of day. Well, I know that every day the patient gets 3 doses. Get rid of that. So I've used everything in my problem. I'm feeling good about it. Cross off my day. So now I have doses. So I have micrograms and doses. Micrograms is in my numerator, dose in my denominator. I've gotten rid of all the other units, so now it's just math. So 0.5 times 1 times 12 times 1,000 is 6,000, I hope. And 2.2 times 3 is 6.6. And when I divide 6.6 into 6,000, it gives me 909.09. And my rounding rule is greater than 10. I round it up a whole number, and 0, I don't round up. So I'm going to give 909 micrograms every time I give a dose to that child. The safe dose is 8 milligrams per kilogram per day, given QID. Med available, 200 milligrams in 5 mLs. The patient weighs 110 pounds. Calculate the dose you will give at 11 o'clock. Well, the dose I'm going to give, well, let's think about it. It's available in milliliters. That's how it comes. So the only way I can give that is in a liquid form. So I have to solve for milliliters. And I'm solving for a specific dose at 11. So I'm solving for a dose. I start with my given, 8 milligrams per kilogram per day. And like I said, it doesn't matter where you want to start. How do I get rid of milligrams? I use what's in my problem. 200 milligrams in 5 mLs. I've used all those. Cross off the milligrams, and look, I got milliliters. I got to get rid of kilograms. Patient's weight is in pounds, so that's 1 kilogram is equal to 2.2 pounds. So use it. That gets rid of my kilograms. Now I have to get rid of pounds. I'm going to use the 110 pounds. Put that over 1. Got rid of that, got rid of that. So now I got the word day and I need the word dose. Well, every day the patient gets what? 4 doses. QID, 4 doses. Cross off day. Look at my problem. I got milliliters and I got doses. Everything else is crossed off. So now it's just math. So 8 times 5 times 1 times 110. Hopefully it's 4,400. If my math is wrong, don't judge me. The setup, you've got a calculator. I'm sure you can knock it out of the park. And then 200 times 2.2 times 4 is 1760. And when I divide 1760 into 4,400, it will give me 2.5, and that is 2.5 milliliters per dose. So I'm going to go into my med room and draw up 2.5 milliliters to give the proper dose at 11 a.m. All right, let's look at this one. Okay, the recommended dose for medication is 800 micrograms per kilogram of body weight every 8 hours. Ooh. The med is available as 20 milligrams in 10 mLs. What is the correct 1600 dose for an adult weighing 80 kilograms? Whole lot of information, but what's my given? 800 micrograms per kilogram. In a day. Now I know this problem doesn't say day in it. That's my error. I just realized it. But not to worry, we're going to work through it. I'll make sure it's accurate on the exam. Don't worry. So what am I solving for? What is the correct 1600 dose for an adult weighing 80 kilograms? I'm sorry, I'm giving away the answer. 80 kilograms. So I'm solving for milliliters because that's how it's available. It comes in a liquid. Oops, sorry. It comes in a liquid and I'm going to give it in a liquid. So that's milliliters. And I'm asked for a specific time and dose. So this is my wanted, milliliters in the numerator, dose in the denominator. So it's the same thing, but it's available in milligrams and it's ordered in micrograms. So I automatically have to be thinking conversion. 1 milligram is 1,000 micrograms. So I can get rid of my micrograms by using my conversion. That gets rid of my micrograms. So now what am I going to use to get rid of milligrams? I'm going to go to my problem. There's 20 milligrams in 10 mLs. Ooh, I got the first part of my problem. I'm feeling really good, but now I got to get rid of kilogram. Well, the patient weighs 80 kilograms. Put that over 1, that gets rid of kilogram. Now I got to get rid of day. So every day, how many doses is this patient getting? What is every 8 hours? Well, every 8 hours is the same as getting 3 doses in a day, because 8 times 3 is 24. So there are 3 doses in a day. And that gets rid of day. So now I have milliliter and I have the word dose. So now it's just math. So 800 times 10 times 80 gives me some ridiculous amount. Now, if you're fancy and you can cross off your zeros, yay. And 1,000 times 20 times 3. When I divide 60,000 into 640,000, it gives me 10.66. And 1 greater than 10, I round to the whole number. 6 is greater than 5. So I'm going to draw up and give 11 milliliters per dose. All right, let's do one more. So what is my given? 30 milligrams per kilogram a day in 3 evenly divided doses. The patient weighs 35 kilograms. It's available in 0.25 grams in a milliliter. And they ask you very specifically, how many milliliters per day will the patient receive? So this question is telling you everything you need to know. They want to know how many milliliters in a day. So I'm showing you this because when it's asking for the whole day, you don't need to know how many doses. It's asking for the day. So I brought this here at the end so you can think and work through this process of understanding these problems. It's asking for the whole day. It's not asking me about doses. So if it's not asking about doses, I don't need to use the doses. So what's my given? 30 milligrams per kilogram per day. But this is asking me milliliters a day. How many milliliters per day? So what am I going to use? I can get rid of my kilograms first. That's easy. 35 kilograms. Put that over 1. That gets rid of my kilograms. I've used that. I've used that. So how do I get rid of milligrams? Well, it comes in grams. 1 gram is 1,000 milligrams. So I'm going to use a conversion. That gets rid of my milligrams, but now I got to get rid of gram. So what do I use? I use my problem. 0.25 grams in 1 milliliter. It gets rid of my grams and it gives me my milliliter, which is awesome. So when I'm looking at my problem, I already have the word day. And now I have my 1 milliliter, my milliliter on my numerator and the word day in my denominator. So now you're done. You're just going to do, and now it's just math. So 30 times 35 times 1 is 1050. And 1,000 times 0.25 is 250. And when you divide 250 into 1050, you're going to give 4.2 milliliters a day.